So this video is the third video in a series that I'm doing of everything that's here on the board having to do with cell membranes and movement of molecules across them. In this specific video, I'm going to be talking about how water moves across membranes. So that's called osmosis. When water moves across the membrane, we call it osmosis. First of all, let's just talk about how osmosis works. If you have solutes that are not able to cross a membrane for whatever reason, then water is going to move from one side to the other. It's going to balance the ratio of water to solute. So let's say that I had more water over here. Then what's going to happen? Because there's less solute, more solute over here, the water is going to switch sides, right? Eventually reaching a balance in the ratio of water to solute on either side. There's less water over here, more water over here, but it's more balanced, okay? Now, to measure osmotic pressure, that's how much the water wants to move to the other side, right? You take the difference in concentration between these two sides, C, you multiply it times the temperature in Kelvin, and you multiply that times the gas constant. It's pretty straightforward, pretty cool, I think. But that doesn't work 100% of the time. What we actually need to look at is effective osmolality, not just this simple definition. We need to look at what happens in real life. And the reason we have this here at all is because sometimes these solutes are able to kind of pass across the membrane. The membrane may not be 100% impermeable. So each different type of solute has this sigma, okay, which is a measure of how easily it can cross the membrane. If sigma is equal to 0, then that means that this crosses the membrane as easily as water. If sigma is equal to 1, that means that this does not cross the membrane at all. So, makes a lot of sense. 1 times whatever we measured here is the same as whatever we measured here, right? 0 times whatever we measured here is 0. So, and remember, 0 means that this crosses as easily as water. If this crosses as easily as water, there's no osmotic pressure because it crosses as easily as water. So it makes a lot of sense. Now we're going to talk about tonicity. Tonicity is dealing mostly with solutions. So you can have different types of solutions. You can have isotonic, hypotonic, and hypertonic. Now an isotonic solution means that if you put the cell in the isotonic solution, it has the same osmolarity on either side, the same concentrations of solutes inside the cell as in the solution. Net movement is 0, right? Because they're moving out, they're moving in, but they're not changing. Hypotonic means that there are less solutes in the solution than in the cell. So the water is actually going to move from the solution to the cell. That causes the cell to swell, and it can cause the cell to lyse, to break. Hypertonic solutions mean that there are more solutes in the solution than in the cell, okay? And what that means is that water is going to move from the cell out into the solution, causing the cell to shrivel up and die. When we're working in medicine, what we really want to look at is these isotonic solutions. That's what our goal is to give patients an isotonic solution most of the time. The reason I talked about effective osmolality here is because tonicity is actually dependent on effective osmolality, not on this. Okay, if we were to measure strictly this and forget about, how freely the solutes can cross the membrane, then we might not get the isotonic solution right. Okay, we could mess up. And that's all for this video.